sl5352 doing EL6303 probability and statistic homework 4. This time I'm asking about we do the question 1 and we do question 2. So begin with the question 1. Given the find draw the capital F y to the y and the lowercase f y in terms of the capital and lowercase of fx. So it gives us mapping ways of how x into y, that is gx, when x less than 0, so y is equals 2, and when x is in the interval of 0 to 1, y is 0, and x in a 1 and 2, the y equals to minus x plus 1, and for all of x bigger than 1, bigger than 2, then y goes to minus 1. So find this question. First things first, we saw about the fundamental theories about how to solve the how to transform the probability density function from x to y. So gives so we first things first, we write the differential of gx, that is 0 minus 1 and 0. But you can see that if we're using the formula that gx equals to 0, then gives a fy, lowercase fy, is almost to infinity, which is not handleable here. So we find that some gx is not continuous, it has a singularity point. So thus yield the fy may contains about the impulse, and it's not always continuous, and it would be very easy to sum about the y as a mixed random variables, which is not the continuous or the impulse, but they mix them together. So think about this. We need to rethink how to solve the problem. That is, to begin with, mapping things. When x is less than 0, so mapping is to 2, and when x is greater than 2, so the y mapping is to minus 1. So this gives us the capital Fy, that when y is greater than 2, that all of the things could happen, and when y is less than minus 1, nothing could happen. So definitely we could get a first clue here, that is in capital Y equals to 1 when y is greater than 2, and capital Y is equals to 0 when y is less than minus 1. And also we could find that we could probably here think about solving the problem. Just begin with writing the cumulative density function, that is in capital Y, and then using the cumulative density function. It's not cumulative. Cumulative probability function, right? So using the cumulative probability function, then to derive into the probability density function. Then we find that when y equals to 0 here, and it should be like the capital Y 0, that is to write the probability of y equals to 0, which is in this part, that you can easily find that x is equal to the x is in the interval of 0 and 1. So it's this kind of a probability are same, that y equals to 0, same to the probability of x goes from 0 to 1, which is capital F x 1 minus capital F x 0. And this is kind of the first uncontinuous point. And think about these three very special points, that is y equals to minus 1, y equals to 0, and y equals to 2, which is all of kind of like a starting point or end point of an interval. So these points are all the the y random variable y is not continuous part. So next we figure out the y equals to 2, which is an the capital Fy2, and z equals to the probability of y equals to 2. Y equals to 2 means that the x is less than 0, so these probability are same with the probability of x less than 0, which is a capital of x0. And same thing as in y equals to -1 here, and y equals to -1 is in x equals to x in the interval of from begin with 2 to the plus infinity. So here we could have plus infinity and 2, so it means x is bigger than 1, bigger than 2, which yields the probability here should be calculated as y minus a capital Fx2. Here we find a kind of like a continuous interval, which y is continuous with x. So we could use the fundamental series theorems that an interval y begin with -1 to the 0, which the lowercase y equals to lowercase x, and using that theory is kind of easy to find that this formula exists. So here we could write, we have already write all of the capital case of Fy and one lowercase of Fy. We could have probably just all of the information we need here to write from the and right now I just need to form the lowercase of y, which in a y minus 1 equals to this one, so have this formula here, and when y is in the interval of -1 to 0, which is this one, this interval, and we could write this here, and for the y equals to 0, which is here, and this capital of x and minus the capital of 1, 0, so gives us the impulse magnitude here, and when y equals to 2, which is here, and gives the impulse response. It's not response. It gives us the impulse magnitude here. It's very easy to find the lowercase y. And about the capital case, about the capital of y, which begin with 0 to 1, and when y equals to when y is in the interval of -1 to 0, so let's give us just do the integral of here, and we could get the 1 minus capital Fx here. And when y is in the interval from 2 and 0, which is only an impulse to raise up the cumulative probability function. So it's like f, the capital F1 minus capital F0, and it could also write as capital 1 minus capital F0 because of the only raise up here. So maybe probably we use a graph to say the things. It's much more easy to understand that we could easily plot the Fy here, which is the -1 is equals to the -1 here. Hold on a minute. -1 here is equals to the impulse magnitude is in 1 minus a capital F2, and when y is 0, so it's like in F1 minus F0, and when y equals to 2 is in F0. And in the interval from -2 to 0, so it's like the x from -1 to 0. It's the same as a graph in a x equals to that interval. So just draw it here. And using this one to do a little bit integral here to get the Fy, which is a step function here, and raised continuously, and another step function here, and all the way is go through to the 2, which is not adding for anything here, and have another step function added to 1. So that is probably the question number 1. Thank you.